Still, people have thought, how would we make hill climbing algorithm an optimal one? Since optimality is one of the criteria that the search algorithms try to or strive to achieve, and that is what we are going to do see next. Okay, so these are the problems, as I told you: local maxima. Okay, ridges, I forgot to tell you what are the ridges. So ridges is another problem which is not there in the graph that is shown, but a ridge is an area in the state space. So we have looked at the state space as a two-dimensional state space, but it may not be a two-dimensional. I may have the objective function so complex that it may actually be represented by multiple curves. So ridge is a multiple curve like this. Okay, so even in natural thing, आपण जेव्हा एखादा कडा म्हणतो किंवा in मराठी we say शिखरांची रांग म्हणतो, तेव्हा त्या शिखरांची रांगा ज्या असतात त्यांच्या दोन शिखरांच्या मध्ये दरी असते. I guess those who live nearby Karjat, Neeral, they might have experienced that there are multiple peaks around Karjat which are having higher and higher tops, higher and higher peak with respect to height. But even though they are closer to each other, if I want to navigate, say suppose this peak, I have to circumnavigate this crest. ये वाला जो crest है, ही जी दरी आहे ती पार केल्याशिवाय मला या पीक वरती जाता नाही येणार. ही दरी पार केल्याशिवाय मला त्या पीक वर जाता नाही येणार. Okay, so this region in the state space of ever increasing value of the objective function, which is kind of cut off from each other. They are kind of cut off from each other because of these in between regions. Because whenever my algorithm tries to optimize anything that starts at this point, I can reach this point, but after reaching this point, since there is a crest, okay, I can't navigate further. Although this region is very much nearer compared to this from here. So if I would have increased the neighborhood and checked more area, I could have navigated it and easily gotten to another local maximum than the current local maximum. So rather than stopping at a local maximum, if in the neighborhood vicinity there is another local maximum which is better than the current, I should get that one, right? Okay, how should I do this on a state space tree? So in the state space tree, this scenario would look like I may be at this point where my objective function value is 8, and all other node which are subsequently my successor nodes, they have values maybe 7 or less. 8 से कम इसलिए उसको मैं 7 लिखा है. But maybe there is a node which has a value 6, which has a child node 9. Then if I increase the locality of reference to rather 2 actions than 1 action neighborhood. So अगर मैं 2 action neighborhood use करता हूँ, 2 action neighborhood means this node also has this 9 node in the neighborhood. If I have a 2 action neighborhood, generally a neighborhood of a node means what? Current node, apply a successor function, get the child nodes, and those child nodes are part of my neighborhood. And I select the best possible node amongst them as my neighbor to compare with myself with respect to objective function value. So if I increase the locality of reference and now 2 action is my neighborhood, or I allow to have 2 actions, then all the nodes which are 2 action distance away from my node, possibly maybe there are few nodes here as well, they all are now part of the locality of reference. So more nodes in my locality of reference, means increasing this width. And if I have a correct increase in the width suited for the given problem. Please understand there are too many complexities. I can increase the width, no issues. If I increase the width, extra nodes in my memory utilization increases. I'm talking about problems which are actually struggling with keeping a lot of nodes in the memory, but I'm trying to improve my algorithm by improving memory. Okay, conflicting goals. ठीक है, तभी भी मैंने अगर अलाउ किया तो क्या होगा, तो मैं इसको नेविगेट कर पाऊंगा, यहाँ से यहाँ जंप कर पाऊंगा, और फिर से मैं यहाँ पे इंक्रीज्ड विड्थ लगाऊंगा तो यहाँ से यहाँ जंप कर सकता हूँ. एंड दिस वे आई कैन नेविगेट दिस region in the landscape which is called as a ridge. So ridge is always an increasing objective function value region which is separated or which is disconnected from each other. So there are higher and higher peaks, but those peaks are disconnected from each other, and it looks something like this. Okay, so this is a ridge. Okay, increasing order of peaks, but they are not connected. So I want to navigate from this point to this point. I should first fall in the crest, then I get an opportunity to increase, go ahead with this increasing slope to reach the other peak. Okay, that is the drawback of hill climbing algorithm. You will say, then why you are using the hill climbing algorithm? I already told you how many good aspects of this algorithm are, because of which for certain problems you may still be happy with reaching this and not reaching here, because we don't know how deep this is. ओके, ये यहाँ पे दिख रहा है, लेकिन ये कहाँ नीचे पहुंचेगा और उसके बाद कहाँ से ऊपर आना पड़ेगा आपको पता नहीं. So those who are happy traveling in nature, they will understand what I'm speaking. When there are ridges to navigate, it is the most difficult part, because you see your goal very much nearer to you, and then you fall into not fall into, you go into a dari or a nest, that is, and get to the bottom of the mountain and then climb up from there to the next hilltop. That is what, that is why it is difficult to navigate a ridge. Many a times people actually have a CD, that is called a CD, okay, or some sort of a way to navigate this directly from here to here. And that way would be, in our case of the algorithm, is to increase the locality of reference. That is, instead of having one action locality, have it 2 or 3 action locality. But then when I have a 2-3 action locality, those many number of times I need to apply my successor function before I get a candidate population of my neighbors. Then I need to navigate for all the candidate population of my neighbors, what are their objective functions, because objective function are something that we calculate, right, for a new node when we spawn that node. After that, I will pick the maximum. After the maximum is picked up, I will compare it with my own node, and that is how I may improve the hill climbing to navigate or circumnavigate, I should say, the ridges. Okay, plateau को कैसे navigate करोगे, circumnavigate करोगे? What could be a solution to navigate plateau? Again, same thing. Plateau is where I have same objective function value for a longer region of space. So maybe I'm somehow at this point, और मैं देख रहा हूँ यहाँ लेफ्ट और राइट में कहीं पे मुझे कहीं पे बढ़ता हुआ कुछ वैल्यू नहीं दिख रहा है, तो मैं क्या कर सकता हूँ? I can actually take a random jump, and then maybe random jump takes me to some other region in the state space which is like this, and then I can navigate a plateau. So I can horizontally allow myself to walk this region, एंड अल्टीमेटली प्लाटू है तो ये वॉक करने के बाद दोनों तरफ मुझे खाई ही मिलेगी, तो कुछ फायदा नहीं है. बट अगर मेरे पास शोल्डर होता विच लुक्स लाइक दिस, और मैं शोल्डर में यहाँ फंसा हूं, तो आई कैन अलाउ माई सेल्फ टू वॉक सम प्लेसेस हॉरिजॉन्टली, जिसको ड्रैगिंग बोला जाता है इन टर्म्स ऑफ हिल क्लाइंबिंग. आई कैन ड्रैग माई सेल्फ टू सर्टन पॉइंट इन द नेबरहुड. ये भी ऐसे ही होगा, आप 2-3-4 एक्शंस को अलाउ करके आपका स्टेट स्पेस का नेबरहुड को एक्सपांड करोगे, सो दैट यू कैन नेविगेट दिस शोल्डर. So as I go in this direction, I would figure out that there is a node which is having a better value with respect to objective function than me, and I can pick that node, and from that node I can navigate next peak. Okay, so that is how you can navigate the shoulder. Shoulder kind of plateau, by the way, is a flat region. If a flat region on one side has a higher peak, okay, then that is shoulder. If it does not have that and it has crest on both the sides, the plateau is difficult to navigate. You have to randomize then your placement on the state space tree. Okay, so these are few of the kind of suggestions that we can understand and can work out to understand how the objective function can be useful in hill climbing. So now 8 queens problem, 4 queens problem, in general n queens problems are the problem, is the very good problem where hill climbing is applied. It's a problem where we want to configure 8 queens on an 8x8 board, and we want to understand the configuration, and we are not into understanding how we arrived at the configuration. So it's a configuration problem. N queen problem is a candidate problem to be solved using hill climbing, and it is a very challenging problem for other search state space algorithm. Please understand that वो मैं convince कर नहीं कर सकता आपको अभी, but you somehow get convince yourself कि n queens problem informed और uninformed search से solve करने के लिए difficult है. And these algorithms, the informed and uninformed search algorithms that we discussed earlier, they are not meant for such problems, to be used for such problems, because these algorithms focus on the path to reaching the goal, whereas hill climbing focuses on reaching the goal. How is not important. Okay, now here again we can use the heuristic function for defining our objective. So heuristic function in this case is the number of pairs of queens that are attacking each other either directly or indirectly. So these numbers are representing, if say suppose I move this particular queen from this location to this location, there will be 18 pairs of queens in the whole board, those will hit each other. That is what this number means. This is the heuristic value. So if in this case I decide to take next move, how many moves are there? I can move this 7 way, move this 7 way, move this 7 way. So 7 into 1 2 3 4 5 6 7 8, 56 child nodes are there, and for every of those 56 child nodes I will have certain heuristic function value, and that heuristic function value will tell me which is the better option to choose from amongst the options that I have. So what is the current value of my heuristic function given this scenario? I need to just count how many queens are attacking each other. So what is the attacking queen? Attacking queen is, the queen pair is like this. So these two are attacking each other. These two are attacking each other. This and this is attacking each other because they are in the straight line of sight of each other. Okay. Similarly, these two queens are attacking each other. So I just want to count the number of pairs of queens that attack each other, and that count for this configuration, they have already done it for us. We won't waste our time in doing it. 17. So what will be my goal for an 8 queen problem? I want to adjust all the 8 queens on the board without no 2 queens attacking each other. So I want a placement of 8 queens such that the number of pairs attacking each other is 0. So my H desirable is 0. And worst case H is some higher positive number. So I need to take this number down to 0. That is how I will be adjusting my hill climbing algorithm. Actually, this is now a going downhill algorithm where the H value I'm trying to reduce. Okay, we are not going to solve this problem, but if I want to apply hill climbing algorithm to 8 queens problem, this is how I would have to define the problem. I would have a full configuration or full representation on the board. I will place all the 8 queens in 8 different columns, and then my algorithm would start counting what is the H value. And then the algorithmic step will try to only replace current node with the next node if my H value is getting reduced. So in this case, 17 is the H value. So if you see, there are many nodes, and there are many nodes with value 12. So these are the nodes which are the candidate nodes to choose from for being the neighbor of my current node. Current state का neighbor होने के लिए ये candidate nodes है जिनका value 12 है, because 12 is the least value of the H function, which can be used as one of the objective functions. So hill climbing can also incorporate domain information like informed search algorithm used for defining the objective function. Here the objective function is defined as I want to have h to be 0. That's my goal node's objective function value. And for my initial state, one initial placement, maybe this initial placement, h value is 17. So I don't want to go from h value 17 to any other h value, that is h value 18, h value 19, the higher h value. I want to go down from here and reach h0. And many of people have tried this out. Now this is same problem. After certain iterations of hill climbing algorithm, the algorithm would halt, and it will halt because in this is a this is a local maxima where अगर आप देखोगे तो यहाँ पे सिर्फ एक पैर अटैक करता है एक दूसरे को. कौन सा पैर वो मुझे दिख नहीं रहा, but you may actually find it earlier than me. There's only one pair of queens which are attacking each other. No other queens are attacking. So this queen does not attack any other queen. This queen does not attack any other queen. This queen I can visually check, right? Visually कि chess आपको पता है queen horizontally, vertically और diagonally attack कर सकता है. Similarly, I don't find any queen attacking each other. Why so? Can you find any pair and tell me if I number the cells from 1 to 8 and 1 to 8 like this? Can anybody tell me which pair is attacking each other? Tell me the queen pairs that are attacking each other. They say there is only one pair and I'm not able to find it out. Somebody who is good at chess.
4 or 4.
Yeah, this and this. Yes, 4 and 4 and 1 and 7. Right? So these two queens are attacking each other. Diagonal attack is there. So this is the only pair which is attacking each other. Now if you check any movement, so ये आपको ये जो अटैक है वो अवॉइड करना है, तो ये दोनों में से एक क्वीन को हटाना होगा. बाकी के क्वीन का प्लेसमेंट तो लगभग ठीक है, ऐसा कंसिडर करेंगे. तो इफ आई एक्चुअली मूव दिस क्वीन ओवर हियर, आई विल हैव इट अटैकिंग दिस अदर क्वीन and this other queen. So now there will be, if I move this queen or if I decide to move this queen over here, okay, what will happen is my h is now 2 at least. इससे ज्यादा बढ़ेगा नहीं बढ़ेगा मैं एनालिसिस नहीं कर रहा हूँ, लेकिन h का वैल्यू 2 तो हो गया. I have found 2 pairs of queens which are attacking each other. Even if I make this queen come here, then also it is at least 1 and 2, right? Similarly, you can check with all the other options. 56 options are there. You see how much breadth of the tree it is having. 56 moves are possible from here as well. So every step I can do any 56 of the moves. Okay, more than 56 actually I should say, but there are a lot of moves. That is what I mean by saying 56 moves are allowed. तो ये पर्टिकुलर जो स्टेट है, इस स्टेट से आप कोई भी मूव करोगे आउट ऑफ दोस 56, all the neighboring nodes will have h value greater than or equal to 1, and that means this is the local minimum. And this is how you can realize what is local minimum by in a problem setting.